Chapter 7, design process. Process is special in terms of the time unit is involved. Sequence is important. Time sequence. Right? Previously, we worked on representation and reasoning. Right? Reasoning also involves. This one is static. There is no time importance. No, it can be done anytime, right? But in reasoning, you need to have some time involved. Say chaining. Chaining is important. Right? Chaining gives you sequence of applying rules. Right? 1, 2, 3, 4, 5, 6. And in processes also. Process is a chain of activities. So in here we say action, activity, similarly action. And here in reasoning we call action is firing of rule. So anyway, here you should see that some concerning about time sequences. Now we are going toward the end of the textbook. Only chapter 8 is remaining. In chapter 7, I will cover only section 1. And Alessandro will cover the other 3, 4 sections. So issues only in my section. And then regulating and planning is two big categories, regulating and planning. Alessandro will explain more about this. But I also has slide on this. So process is similar to controlling and selecting and ordering. Ordering is a sequence ordering operators. And there are two kinds of control in this textbook. There is make decision just before the action. So they call this is a regulatory decision making. Similar to say when you drive at the intersection of street, you see that signpost or lighting, then you decide whether to go straight or stop or turn right. Right? So it is very immediate, just before the action. The other one is planning. Planning is very big bird view. Reasoning about actions well before implementing or actions. Right? So, and then in this way, you need to have a explicit plan of processes or activities. And in issues, you see that regulating and planning, two different types. Regulating is just before the action, and plan is well before the action. And abstraction level is also important here. Level of detail, I show you with the Google Earth. Level of detail. Google Earth, you see it focusing, zooming in into my. When I was visit the Google headquarters last summer, and they show a Google map on the big wall screen. And everybody stay there to find his home. So I tried my home too. Right? It's interesting. Goes into the Korea, South Korea, and Daejeon, and then see, and there is my home. And that we call the level of detail. of image, satellite images they're using. Similarly, there is a abstraction level. And abstraction level divided into design description, representation, and action or reasoning, action abstraction, and also control process abstraction. It is similar but different. And conflict and decomposition. There is also any time there is a conflict of sub-goals or something. Right? Inconsistency, uncertainties, something like that. So regulating and planning, regulating is decide which action to fire just before, right? Just next. Planning is reasoning about design actions well before, far away, so independently of their implementation. The implementation is very close, the separation of action and planning. So decide on sequence of actions well before executing them. So I'm trying to go to the Busan today. Right? In my brain, I'm planning to what to do. Right? What to do? Go to the try to catch taxi and go to the Daejeon station. But nowadays, smartphone gives you a well-planned sequence to me, right? All the actions. So planning. Also rehearsing process well before committing the task. So in manufacturing world, we call this is a computer-aided process planning, or in other words, tool path simulation service. The machining, drilling machine, milling machine. Right? So we have a design to make say this mouse, the cover plastic molding. The mold should be made in iron or steel, and then machined as this surface, curved surface in the machine. Then we can cook this one. How can you, the tool is milling in this way. Right? That is we call the tool path planning, or computer process planning. And then the output is a program sequence. Very similar to robot plans, robot machining. Robot is working and grasping these whole control actions or command sequence of all the motors and sensors and controllers. Right? Very similar to milling machine. Milling machine should have a long list of command sequences for the machine to make such a machining of the surface. So that we call the planning. Right? So regulation is similar to what should you are trying to cross the stream or river, shallow. Or what is next action? Jumping. Right? That is regulating. But planning can be something like this one. You need to have a bird view first. Right? Bird view first. You need a map. And then find out best way to jumping sequence. Otherwise, you need to return back to another position, old position. Abstraction levels, level of detail. Three kinds of abstraction hierarchies. Design description, and design action, and also control or process. And so in higher level, we call this as a strategy in say, military world too, or in this industry, company-wise. And there is task level, and then the smallest one can be an action level. And then also we talk about economy of abstraction. Because this way, to design buildings on paper is less expensive to make a prototype, real building. Right? So we can, this is a kind of simulation. Planning is simulation. Computer simulation. Computer model is less expensive than prototype. So, when you develop a new car, concept car, new car for the, or new smartphone for Indian ladies, they usually make a prototype about 10 prototypes, depending on the program or depending on the design. How big jump is coming, then you need a more prototype. Prototype means a real size, same machine, but handmade. But after that, it goes on to mass production. Right? Very different. Prototype making and mass production is very different. For the car, one or two prototypes manufactured before mass production. Handcrafted car, new car, very expensive, long time to make. But you need such a prototype. So nowadays, they want to do more computer simulation rather than making prototypes, because it is expensive and especially takes time. Because see, they need to develop a new design, new model every 6 months, Samsung, or every 3 months. But designers and prototype making engineers, they are very busy. You see, every day they create new prototype, drawing is coming. So computer model is less expensive in terms of money, in terms of time. But nowadays, time is more important than cost, actually, for the product. So this is already shown to you several times. For the building, apartment, rooms, arrangement. And what is this? Actions. Right? Place bolts in a hole. Then you need to, before then, you need to have aligned holes in A and B. Before then, you need to place a hole in A, place a hole in B, and then put A on B, onto the B. Bolt A to B. Right. So this is a final stage. You need to have a pre-actions, something like that. So sequence of actions for the assembly. For the assembly, you need to have a sequence of actions. Okay. And what is this? That can be a final stage. Assembly, finished assembly. But before then, you only have a parts list. Right? Then how do you do that? So action, fix A to B, place B on C, connect C to D, and then fix to A, and then place and put, and something like that, and finally this. We call this assembly sequence. So action, very similar to I'm planning to go to the Busan today. Right? You need to have an action sequence. And final is conflict and decomposition. Decisions cannot always be made independently because something is not clear divided. There is a dependence between actions, decisions. If I choose red color, then somebody don't like red colors. Right? For the smartphone for Indian ladies. Right? So decision, there is some clear cut. There cannot be a clear cut. The actions conflict with one another. Partially, not partially, always partially. Why the order in which actions are implemented generally matters. Right? If I change the sequence in reverse way, what happens? If I go to the Busan and then call the taxi and then buy ticket, but if I switch ticket first or taxi first, bind cap. What happens? It does not matter in this way, right? But if I opening the door must be first. So stacking on top of each other, that is a simple problem for that. The sequence is important. So impossible to proceed without undoing, backtracking some action already performed. That is important bottleneck sequence. So initial state, and then I want to arrive at this end state. So this one is good, but this one is not good. So we need to cancel the action, right? So this one and this one. So retracing, trace back, retracting. That is, anyway, here once again you need to think about the sequence is important. Time domain, time unit is important. Question? Do you want to use this one?